In this video, we're going to be talking about limits, specifically a limit of a function. We have our notation written right here. We have this lim, which stands for the limit, of our function, which we're going to use f of x. And then below the limit, we have this x, and then this arrow, and then a. Now what this part right here represents, this x arrow a, it stands for as x approaches a. In other words, it's what's going to happen when x gets very, very close to a. So the notation that we have up here would be pronounced the limit of f of x, so that's our function, as x approaches a. In other words, when x gets very, very close to a. Now let's take a look at this graph that we have down here. Now a is going to be a particular x value, so let's say a is right here. And then I'm going to call this L for a moment. Now we're not quite done with the notation up here. What we want it to say is that the limit as x approaches a of f of x equals L. Now L is going to be a specific y value on this graph. So if you take a look at this, when x is just any one of these x values down here, as x gets really, really close to a, so you're moving along this graph, when you get really, really close to a, what it's saying is that the y values should get really, really close to L. Which you can see if you were to follow this graph, as x is moving along the x-axis, right? And you're getting really, really close to x equals a, that the y values are getting really, really close to this y value L. Now that's how we're going to interpret this notation. And this is how we're going to talk about limits of a function. But let's bring out a specific function and look at how it works. Now we have this big piecewise defined function up here. So what we're going to do is take a look at different y values or different x values and see where it looks like the y value is going. So let's take this part of the graph right here. Okay. Now if you were to follow along on this graph, notice that we're moving along the x-axis down here, and you can actually watch the x values change over here. When we're getting closer and closer, let's talk about this point right here. So that is when x is -3. So let's see what happens when x gets really close to -3. Based on the graph, what would you expect the y value to be? And so it'd be 1, 2, 3. So it looks like when x is -3, the y value should be around 3. So if we're moving along the graph, you can see the x values are moving closer to -3. Okay, and here are your y values. You can ignore these two for now. We don't need them for now. Alright, so here are my y values. Is it getting close to 3 as we're getting really, really close to x equals -3? And we're pretty close, 2.99. Now what happens if I go on to the other side of -3? So now we're at like -2.8. You can notice that now we're going down. Right, you can see that happening right here. So if we go back up, again, what's the limit as x approaches -3? It appears to be the y value of 3. We're really, really close to it. So how can we write that? In our limit notation, we would say the limit as x approaches -3, right? So as x approaches -3, okay, we have a corresponding y value of 3. Now what this is it is the expected y value. Okay, the difference between limits and the actual y value right here at that point, okay, a limit is only talking about the expectation of the y values. You know, when you're moving along the graph, all right, when x gets close to -3, what are we expecting the y value to be when we hit that point, or when we get really close to it? We expect it to be 3. We don't actually care about what it is when we're actually there. It's more, limits are only talking about what would we expect it to be when we get really, really close. So let's go ahead and talk about another point. Let's say this one right here. So I'm curious about the limit as x approaches 2. This is an x value of 2. Let's see what the y values would look like. Now we expect the y value to be 0 because it's on the x-axis. So here are my x values. Let's see what happens. So we're moving along the graph. All right, you can see the y values changing. They're getting small. Okay, they're getting really, really close to 0. Okay, when we get really close, okay, looks like we're getting close. Now let's change the x value to be like 1.9. Okay, we have a y value of negative 0.05, so that's pretty close. How about 1.99? All right, now we're getting really close to 0. How about 1.999? You can see how when I'm getting extremely close to 2, my y values are getting extreme. This is in scientific notation now, but these are very close to 0. Right? How about when we're on the other side of x equals 2? How about 2.01? Okay, you can see that it's negative 0.005. How about 2.001? Okay, very, very close to 0 again. Okay, if I keep doing this, right, we're getting numbers very close to 0. So how would we write that? Okay, down here, we would say the limit as x approaches 2 of my function is going to equal, now it's the expected y value. Okay, so we expect it to be 0. By the way, is the y value at x equals 2 0? And it's not. Okay, there's my y value. This is actually the point 2, 1. So the y value is not actually 0 when you get to x equals 2. Because that's, again, the limit's only concerned about what do we expect the y value to be when we get close to x equals 2. And we expect it to be 0. It doesn't happen to be 0. But again, that's not what the limit's concerned about. So we had our two examples. The one up here where we expected the y value to be 3, and it actually happened to be 3 when we get there. Okay. This example down here, we expected the y value to be 0. There was no point there to give me a y value of 0. But again, the limit told me I should expect it to be 0. So we have two different scenarios. Both a limit's existing. Okay. Here it's 3. And here it was actually 0. The last example I want to talk about is when you're approaching negative 2, okay, on this part of the graph. So I'm not ready for that example. Let's go back to this example here. Now, we noticed that when x is getting really close to the x value of 2, our y values were getting really close to 0. But notice that that's true when we come at it from both sides, right? We expect the y value to be 0 coming from the left, and we expect the y value to be 0 coming from the right. So these are called left-hand and right-hand limits. Okay, so referring to this point right here, okay, we have an overall limit, which is basically saying when x approaches 2, this is when you don't have a direction, it's just saying when x approaches 2, then that's an overall limit. It means no matter what direction you come at that point, we expect the y value to be 0. Now a left-hand limit, the way it's written is the limit as x approaches 2, but it's giving us a direction. We have a little minus sign there. Now the minus sign tells us we're coming from the left. Now when we're coming from the left, it equals 0. We know that already. Now when and then we have a right-hand limit. And the notation would look like this. It would be the limit as x approaches 2, and then we'd have a positive sign, which stands for coming in from the right. We also expect it to be 0 because we already saw that. Coming in from the right, we would expect the y value to be 0. So let's take a look at this part right here. Alright, so this is an x value of 0. What happens when we get really close to it coming in from the left? Okay, it looks like our y values are getting close to negative 0.4. Let's see what happens. Let's get really, really close to 3. So how about 2.999? Oh, it looks like we are getting close to negative 0.5. You can see that. Okay, right? We're getting close to negative 0.5. So that means our left-hand limit coming in from the left, we expected the y value to be negative 0.5. Okay, so let's write that down. We have the limit as x approaches 3 from the left, and we just said that we expect it to be negative 0.5. Okay, so let's see what happens when x approaches 3 from the right-hand side. What are we expecting the y values to be? So we're moving along the graph. It looks like we're getting really close to that point right here. Alright, so if you're watching these y values, when we get really close to 3, how about 3.001? Alright, it tells us the y value is going to be negative 1. Okay, sometimes when you get really, really close, it's just going to tell you right away what the limit's going to be. So if we did 3.1, you can see you're close to negative 1. 3.01, you can see we're getting really close to negative 1. So we do expect the y value to be negative 1. But we're coming in from the right. So that's going to equal negative 1. So notice that coming in from the left and coming in from the right, we actually approached two different y values. So our expectation was different depending on which way we're coming in. When something like that happens, where the left-hand limit, which is right here, and the right-hand limit don't equal each other, right? These do not equal each other, we have a general limit, which is written like this: when x approaches 3. Notice I do not have a side right here, so this is what we call a general limit. It does not exist. Okay. So what can we get from this? Well, if we come down here, we can say that the limit as x approaches a of f of x is going to equal L when the limit as x approaches a from the right equals the limit as x approaches a, sorry, this is from the left, when x approaches a from the right, and when they both approach the same place. So our general limit, which is right here, okay, is going to equal a y value, or yeah, it's going to equal L, some specific y value, only when the left hand, which is right here, and the right hand limits equal each other and specifically equal that same L value. Okay, so I do want to go over one more example, which is this one right here. Now what happens when we, here's x equals negative 2 right here. What can you see is happening to this graph as we're getting close to negative 2? You can see my y values going down, right? And they just keep going down. Now if we come over here and I said negative 1.99, you can see that we have this y value, negative 1.6. What happens when we get really, really close to negative 2? You can see these y values just keep going down and down and down, and they just keep going down. So we know that as x gets close to negative 2, that it looks like we're going down to negative infinity. So we can write that as x, the limit as x approaches negative 2, but notice that it's only when we're coming in from the right. When we're approaching negative 2 from the left, we're actually up here. So that's a different case. But when we're approaching it from the right, it looks like we're going down to negative infinity. Now, negative infinity isn't an actual number, okay? But this is, again, talking about what we are expecting. So we expect, when we say negative infinity, think of it more as a direction or a place. We are going down to, in other words, we're just going to keep getting larger and larger negative y values.